It's only me, and we start. Okay, we are doing the second page of the review. In the second page of the review, you have doing transformation one more time. I need to do the graph of the function g of x equal square root minus x plus 2. This is the case in which is to see the transformation, because I saw something. No, this is belong to the family of the function que is square root. This is the basic. But I can see transformation. What transformation? The first transformation is reflection. So this is reflection. Reflection. Reflection about x, y-axis. And it's no clear. Well, I see that we have inside the radical plus 2, no? And this plus 2, I don't know very well. I know that it's horizontal shift, but I don't recognize in what direction, because this negative is a little bit confusing. But don't worry too much. I apply, for example, a factor out -1, and we have x minus 2, something like that. And this expression is equivalent to the original, because you apply distributive property here and here. We have minus x plus 2. Entonces es actually is horizontal shift 2 units to the right. Do you follow me, guys? Do you understand very well this or no?
Yes.
Okay.
Yes.
Sure. Cool. Now, let's go to the graphic. We start at the beginning with the famous square root function, y equal square root x. Okay, it's easy. Look, let me show you. You plot the different points. At least 3 points is enough. Suppose 0. 0 is 0 because the square root 0 is 0. 1 is 1 because the square root 1 is 1. And 4 is 2. This is the typical, little bit, no, approximately, the square root x. This is this. Boom. Now reflection. Reflection, I know, get the image in another direction, another semi-plane. This is here, and this is here. Let me use another color, no? I try to do my best. Okay, this is square root minus x. And finally, minus 2 get plus. So it's in opposite direction, point by point. For example, let me use in red color, I like so much. That point gets 0, 0 now become like it's 2. Right? Because you're moving 2 units to the right. That means that any point, for example, this is -1, plus 2 is -1 plus 2 is positive 1. No? And this is -4 plus 2 is -2. -2, okay, -2, that point is -4, now -2, comma 2, yeah, comma. So this is my graph, look like that. This is the graph of this guy. Okay, doing approximately, no, by hand. Do you follow me? Do you understand very well or no? Of course, we can do that using Desmos. Okay.
Professor, can you do another one? I don't really get it.
Another one of similar to this?
Yes.
With the square root or no?
With the square root.
Yes. Okay. Suppose this. Another function que is equal For example, cubic root, no. Cubic root, yeah, why not? Cubic root, cubic root. Cubic root, cubic root. Cubic root, cubic root of x plus 3 minus 5. Okay, it's doing it. This is easy.
Professor,
Uh-huh.
can I get a clarification really quickly?
And the,
So
uh-huh.
gx is for x, right? And y and fx is for y.
Yeah,
Okay.
yeah, absolutely.
Okay.
Okay, listen. And you need to be familiar with the function notation. When you declare f of x or g of x, this is y. This is y equal this. That suppose that you don't like using function notation. Okay, no problem, I understand. Now you write like that. Look, you write like that. This is y. This is y. You erase this is y. Okay? Okay, now the function notation, f of x, g of x, open the door to understand the transformation and another things because we can see in one compact expression, you can see this is y, you know, but this is x, and you see both together, right? Make sense? Make sense?
Yes.
Okay. Okay, so you want one more example or no? The lady que proposed me, Professor, doing another one, okay. One more or no? Yeah, I copy that. Yes, okay. Who are you?
Sophia.
Introduce by, who are you?
Yeah.
Your name.
Oh, Sophia Adolph.
Sophia Adults. Okay, Sophia, look. You realize that function belong to the family of cubic root. Yes or no? This is the mother. This is the basic function to generate a family of the another function when you apply transformation. And I need to know que cubic root look like that, 0, 0, 1, 1, -1, -1, and suppose, wow, this is enough, because another is cubic root of a que 2, and a is outside, approximately look like that. Okay, in this case, the domain is all real number. We have positive and negative. This is the graphic of the cubic root of x. Guys, you can check it in the paper I sent to you of the library of the function, the most common function that we are using in this subject. Now, you see the transformation. The transformation you see is, look, you see according to the order of operations, let me using another color, you see this transformation first. Yes or no? And what means that? X plus 3 and the function notation. So the thing we are doing is, and the function notation is equivalent to say x plus 3, something like that, right? And it's a horizontal shift. Yes or no? In what direction?
To the left.
To the left. To the left. To the left, exactly because it's plus. 3 unit to the left. 3 unit to the left is this point reaching out is 0, 0. Now would be -3. So this point is 0, 0 in the base C. Now in the new one, no, in the partial is 0, -3. And this point is here. This is moving 3 units to the left, and this is moving 3 units to the left. 1, 2, 3. So my new, let me use in blue color, look like that. I try to do my best, guy. This is cubic root x plus 3. Makes sense?
Yes.
Yeah.
Okay. Now -5. What mean -5? What mean -5? When you have f of x is equal f of x plus 3, I did that part, minus 5. And this, now I focus see, and that part, chuk, chuk, minus 5. What mean minus 5? What kind of transformation it is? What kind? What kind? What kind?
Reflection.
No, no, no. It's vertical shift. It's vertical shift. When you adding or subtracting one number outside is vertical motion. Reflection is when you multiply by a negative one. Multiply, no addition. Make sense? No? Confusing?
Yes.
Confusing. Everyone is confusing.
No.
Look, 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 look. When you have a function and you adding plus one number or subtracting, this is vertical shift. Clear? Reflection. Oh no. Reflection, the only thing you should do is replace x for negative x. This is one kind of reflection. Another reflection is f of minus x. This is about y-axis, and this is about x-axis. So reflection indicates us multiplication by negative 1. Okay? And vertical shift, no, it's addition, plus or minus, no? Depending si es upward, positive, downward, negative. Make sense or no? And horizontal is similar, but inside the parenthesis. This is a horizontal shift. In this case, si es horizontal, we have two possibilities. When it's positive, left. When it's negative, right. In few words, I condense in the most important information that you need to remember to understand transformation. Make sense? Come on, come on. Question.
Yes.
Maybe yeah, Anika. Okay, Anika. Look, and now minus 5 is horizontal, no, vertical shift. In what direction? To the what direction? Upward or downward?
Downward.
Exactly.
Downward.
Because it's negative. Entonces, any point, you subtracting 5. For example, that point, que es 0,3, would be now here, minus 5, minus 3. Because I'm moving point by point. Okay, one good idea is you plot 3 points in the base C. And you transform it, using the rule. Now this point here and this point here. Our new graph look like that. I try to do my best. This is the graph of this. It's okay? It's okay, Anika?
Yes.
Cool. Okay, now let's move on to the next question. Okay, I want to erase everything. Okay, no, not here, like that. Okay, cool. Now what the next question? The next question is about identification algebraically, determine algebraically whether the given function are even, odd, or neither. Let me refresh your memory. Even function is a function that when you are doing this reflection, nothing happens, it stays the same. And this is classical. For example, any graph que es symmetric with respect, suppose like that, symmetric with respect to the y-axis, is a classical example, is even function. Because you pick one x and you obtain one y, and when you pick negative x, you get exactly the same y. This is the interpretation, geometric interpretation, and this is the algebraic proof. And odd is also reflection, but another kind of reflection. Is when you replace x for negative x, when you try to prove algebraically, the only thing you should do is taking in the original expression and you replace x for negative x. You perform reflection and you analyze the answer after the reflection. Entonces es equal minus f of x. Wow, magically. This is classical in which the reflection across or about y-axis is equal the reflection about the x-axis. And it's a typical symmetric, but what kind of symmetry? Is symmetric with respect to the origin. Look at that. Suppose that the function look like that, and the other function look like that. So when you pick one value of the x, you get one value of the y. When you pick negative x, okay, suppose that here, I don't know, you pick exactly the same value of the y, but on negative sign. And this segment and this segment is the same. Sorry, my sketch is no good, but this is the idea. Otherwise, it's neither. It's neither. Entonces, you need to know that because in the future, in the chapter 3, we are doing the graph of the complicated functions, and you need to investigate symmetry. Symmetry. And we have two kinds of symmetry. Symmetry will respect the y-axis, the function is even, and symmetry will respect the origin, and the function is odd. Otherwise, no symmetry. And no symmetry is bad. Well, it's not bad. It's more complicated because you take advantage. The symmetry, when suppose that the positive part, the top part, is equal the negative part. Fantastic. I only care the positive part because I know that the negative part is the same. Okay, and here, well, you take the positive part and the negative part is not exactly the same, but it's the same number but the opposite side. Cool. So let's do it. Let's do it. This is the theoretical part of the even, odd, or neither. Okay, now let's do it in the specific problems. You take the first problem, okay, called number A, letter A, no number, is the function f of x equal 3x squared plus x to the 6th power and plus absolute value x. Wow. Wow, look at that. Using intuition. Using intuition. The exponent, and this is 2 is 6, the absolute value. And you need to be familiar with this. A square, so any polynomial, any power function, can have exponent even, look like that. This is the classical parabola x squared. X to the 6 is very similar. A little bit more flat in that part. This is x to the 6th power. This is obvious that this is even. Alone. This is even alone. An absolute value and the collection of the function that I sent to you look like that. This is the absolute value. However, the linear combination of this function together, obviously is even. Okay, but this is just intuition. Okay, no problem. I don't know anything. I replace x for negative x. It's the classical idea. 3 negative x squared plus negative x to the 6th power and plus absolute value negative x. Okay, so now I compute that. Wow, it's easy because negative squared positive stay the same. And any exponent gets even. What's the reason? One of the reasons is because you can interpret it, for example, negative x squared is equivalent in my mind like a negative 1 times x squared. And negative 1 is squared times x squared, negative 1 squared, a positive 1, this is x squared. On the shortcut to do fast, when you see that the exponent is even number, disappear the negative. When it's even, no. When it's, sorry, when it's even, it's positive. When it's odd, it's opposite sign. So this is exactly the same. And you know very well the absolute value of negative quantity is positive. So now you copy exactly. And we compare this and this. Wow, it's the same. It's the same. It's because the function is even. Cool? Cool or no? Answer me.
Yes.
Okay, I can see.
Yes.
This is the review. This is important because my intention doing this and dedicate time in this is because I want to make sure is review, recall again. Suppose the b, the b is the function g is equal x cubic plus x plus 1. Using intuition, what do you think? Is even? Is odd? Or is neither? What do you think? Using intuition. Maybe your intuition is odd. Another student believes it's odd because the exponent is 3, okay, and here the exponent is 1, is invisible, and 3 and 1 are odd number, no? But what happened? Yeah, it's odd. No, Anika, no. No, it's not odd. It's not odd. Let me explain why. Because, okay. Let me explain geometrically and algebraically. Look, cubic function look like that. It's obvious que this alone is odd. Linear function is a line, chung, x to the 1 power. It's also odd. However, 1 is a horizontal line, so the function y equal x cubic, the function y equal x, and the function y equal 1 is a horizontal line. And this is odd or is even. This alone. This is y equal 1. This is y equal x. This is y equal x cubed. This is odd or is even?
If we raise to the power of 0, it's even.
It's even, it's a constant. And how do you see? Looking using eyes, no algebra, que es even, because it's symmetry with respect to y-axis. Yes or no? That part, good, and that part is the same. That part and that part is the same. And so we have a combination. This is odd. This is odd. And this is even. Wow, what the hell? I don't know. So using intuition, well, doesn't work very well. But in the majority of the scenario, when you have a combination of the odd and even together, it's because it's neither. But okay, I suppose que I don't know. Entonces, let's use in the traditional way, the formal way, que es replace. You are doing reflection. And let's see what's going on. This is minus x cubic plus minus x plus 1. Entonces this is obvio que es minus x cubic, this is obvio que es minus x, and this is plus 1. Entonces you compare this and this. ¿Es the same? ¿Es the same?
No.
No. ¿Es completely opposite sign?
No.
No. Entonces es no. Si es the same, es even. Si es completely opposite sign, es odd. Entonces es no even nor odd. Entonces es obvio que es neither. Make sense?
Yes.
Cool. Es Elsa, ¿no?
Yes.
You feel better?
Yes. Thank you.
No problem. Okay, you understand. Cool. I like it, the student understand. Okay, so you ask me, I try to find the best way to explain everything. Let's do a number C. Number C is confusing. What do you think? Using intuition. Es even, or es odd, or es neither? I have no idea. Complicated. And sometimes it's hard to see intuitive idea about this. But don't worry too much. You are doing the reflection. This is the algebraic way. Es minus x cubic over minus x squared plus 1. I know very well that when the exponent is odd, it's negative. Negative x over, and when I know very well that when the exponent is even, it's positive. Now I compare, but no yet. But wait a second. I forgot 3 here. It's 3. Well, to compare clear, at least for me, you put this negative outside the game. It's equivalent, no? Because it's a fraction. When the fraction at the top is negative or the bottom is negative, the entire fraction is negative. So you put a negative in the place that you want. You put outside and the front to say you have this. This is the crucial moment to compare this and determine si it's even, odd, or neither. What do you think? Opinion.
Odd.
Super. Es la idea. Eso.
Professor, how can you tell if they're odd or even or neither again?
Repetition again for you, miss. Even is when the function after the reflection stay the same. Nothing change. Look, in this case, change something because you have extra negative here, right? And odd is when you are doing the reflection, suddenly, magically happen you have extra negative outside the function. It's exactly the thing that happened. This negative is this negative. Do you see?
Yes.
Otherwise, another weird is neither. Otherwise, but no. In this case, odd function, obviously. Clear?
Clear.
Let's do in the last one. And the last one. And the last one of this question, because we have 4 questions inside 7, no? Is the function p of x is equal x squared over x to the 4 power plus 4. Oh, using intuition, everything is even exponent, and plus 4 is also constant function. I predict que es even. I predict. However, I make a reflection. Make a reflection, we have at the top minus x squared, in the bottom minus x to the 4 power plus 4. It's obvious that this stay the same, is positive. It's obvious that it's positive also. And when you compare this guy and this guy, wow, it's the same. Therefore, the prediction was okay. It's an even function. Cool?
Yes.
Cool.
Cool. It's easy. Anika, yes. Okay. You know, guys, the mathematics is not too hard. The problem is that you need to focus, you need to pay attention, and you need to remember the rules. You know, I am not good at mathematics because in the high school you don't care. But this is the college. In the college, you don't care. Well, you don't pass. And the penalty of this is that your GPA is decreasing and your money is decreasing because you need to pay again the class. Okay? This is the rule of the college and university. Okay, let's move on to the question 8, que is super easy. One graph is given, complicated. You know, sometimes we have a hole, so we have sometimes open points, and we have close. Entonces, include, no include, I don't know, I am confusing. Entonces, you evaluate, but you don't have the expression of this. No, you have the graph. So F and 4. You try to find. This 4 indicate us X value. Belong to the domain. So this is the X-axis. You try to find 4 in the X-axis. Here. Oh, I found 4. And you try to find, you moving maybe upward or downward, depending the graph, until you touch, bang, the graph. And the answer you see in the y-axis is 6. Makes sense? Makes sense? Yes or no? And
Yes.
negative, and negative 2, and negative 2. Negative 2, I suppose que here. Entonces you need to use a little bit imagination in the test, because sometimes the graph is not clear 100%. Don't expect that. This is to confuse you. And you here touch here, and you see in the y-axis que suppose que es negative 2, and the reason is que negative 1 is negative 1, and this is linear, so it stays the same proportionally que es, 1, 1. So negative 2. Makes sense? F and 2. Well, 2 is complicated, guys, because 2 is here. So you find when they have a close, no here, a close, que es, I suppose que es 4. And 0 is, well, 0 is here. The point is 0, 0. 0x, 0y, 0. Negative 1. Negative 1 is very, very confusing, because negative 1 is here. In what direction I'm moving? I'm moving upward or downward? Oh, no, upward, because I see here that the circle is completely full and it is empty, and the function is defined in the full, not in the empty. No, the answer is 1. Do you see that or no?
Yes.
And negative 4. On a negative 4, negative 3, negative 4. We continue here. This line is infinity forever. So it's negative 4. And negative 5. Oh, the same stupid thing. And negative 5. And positive 5. Oh, no. And positive 5 is here. Positive 5. Again, is 6. Exactly like in the first question. Because it's a constant function. Look. It's extending forever. Constant 6, 6, 6, 6. F and 6. It's obvious it's the same stupid thing. And 7. Same. Any question? Any question? Any question? Any question? Come on. Do you understand very well how we evaluate the function? Of course, I put the hard. I put the piecewise function, no? And you need to be clear. No question. Very easy. Okay, cool. It's exactly I want. Okay, now, the question 10 is looking the graph, no operation. You look in the graph, determine domain and range. Look in the graph. Okay, let me make it zoom to see more clear the graph and express the answer in interval notation. Okay, the teacher explained me que the domain is the set of the x value in which the function is defined. So you take arbitrary point on the curve, in this case a line, and you projecting onto the x-axis. I know the projection look like, in my opinion, like that, and like that. Unfortunately, in between 2 and 3, I create intentionally a gap in what the function have no value, no? Okay, no problem. However, include 3, how do you know? Because it's close and not include 2. And it's extending in both directions, negative infinity and positive infinity. Okay, so now let me write formally. Domain of the hypothetic function is given in the graph and the test is equal is from negative infinity, comma, to parenthesis, union, because it's 2 pieces separately, you know, is bracket 3, comma, infinity, es bracket because include 3, es paréntesis en 2 because no include 2. And the reason que include or no include is because you see here the circle full and here the circle empty, indicate it's not defined in this value. Cool? Cool? What about the range?
Cool.
What about the range? Well, the teacher explained in the lecture that the range is the set of the y value and what the function, on which the function is, yes, it's defined. Si it's undefined, no, it's outside. So again, you take the point, bam, 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 on the line, on the curve, whatever, and you projecting now onto the y-axis. And the projection onto the y-axis, in my opinion, I don't know if you see or no, look like that, because I see projection below 3. For example, in 4, in 5, and 6, we have no y value. It's completely out the range. But this continue forever. Let me see. This continue forever in that direction. Okay, minus infinity, no? Okay, and what about the last point and 2 and 3? Well, 2 is okay, because here is defined, but 3 no. So it's here, parentheses. So basically, remember the interval notation, you put the first the lower bound, okay, minus infinity, comma, 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 3, no include 3. It's the answer of the range. Okay, so you exclude out the set, the holes like that. This is the holes. You exclude the gap like that. And one of the part is not defined when you projection. For example, that part is no hole, no, but it's completely out the range. Make sense? Do you understand very well?
Yes.
Okay, let's move on to the next page. Yes. Next page, next page, next page. Next page. Uy, uy, uy. Next page. Next page. It's this. Okay, cool. Okay. And this page, we have a combination for the functions. Okay, combination of the functions. Combination of the function. Okay, first of all, okay, we have function f of x. We have a function f of x. Is 7x squared minus 6x. Okay, cool. Semicolon, and you have a function g. It is x squared minus x plus. And they want to know the expression que represent the combination f division g of x. Oh, it's easy. You put the f in the top, it's a fraction, it's division. You put g in the bottom. Okay, and end the story. Get the answer, right? However, the complicated part is not this. The complicated part is always stay is domain. Because I need to remember, well, the professor explained me in the lecture that when you have P divided by Q, okay, I need to investigate que Q not 0. Because division by 0 is undefined. So one, in this case, I need to investigate si x squared minus 2x plus 24 is not 0. It's my domain. I need to investigate that restriction. Okay, this is relatively easy because immediately I convert this to quadratic equation. And to solve the quadratic equation, I propose you the quadratic formula. A is 1, B is -2, and C is 24. I'm plugging in. And the formula minus B plus or minus the square root B squared minus 4AC divided by 2A. Who is B? It's -2. And when you plug in the formula, become positive because you have two negative. Plus and minus the square root minus 2 squared minus 4 multiplication by 1 gets A, multiplication by 24 gets Z. Divided by 2 times 1 because A is 1. So you focus as always on the operation inside the parentheses, no? The parentheses, no, the radical, sorry. Here, So you compute, this is negative 2 squared is 4 positive, minus 24 times 4 is 90C, I guess so, no? Let me check it out in the calculator. 4 times 24, okay, it's 96. Now, wow, it's 92, no? Minus 92. Inside the radical, give me imaginary number. And remember, the supposition in that chapter of the domain is all real number, and of course you exclude some restrictions, and the restriction I investigate here. I obtain imaginary number, and imaginary number is completely outside this. That means when this imaginary is because do not exist restriction. Therefore, the domain is all real number. End of story. But you need to investigate. This idea is clear or confusing? This idea is clear or confused? Okay, answer me. No problem. Clear. Anika.
No.
A ver, who more? Anika again. Clear, clear, clear. You copy? Erase? Yes.
Yes.
Okay. Let me go to the number 12. Number 12 is, you have to function also. This is super easy. And I don't know why the student make a mistake in this question. This is really easy. 5, sorry. 5. Semicolon, GS x plus 3. And they want que you compute f plus g evaluate 3. Que you need to know que this is equivalent f evaluate 3 plus g evaluate 3. Wow, entonces super easy. F evaluate 3. You plug in 3 here, 2 times 3 squared plus 5. 3 squared is 9. 9 times 2 is 18, no? And 18 plus 5 is 23. At least I have that value. And g is easier. Is 9, no? So 3 plus 6 is 9. Now finally, this is 23. This is 9. And this is 32, no? 32. Ah, this is a piece of cake. No problema, guys. I suppose que no problema, no?
No.
No. Oh no, this is a piece of cake. This is elementary, straightforward. Yes, easy. Okay, let's move on to question 14, is the classical question about the different quotient. It's a little bit confusing. Different quotient is a formula like that. This formula somehow involve function notation. That. Now, f of x is given in this specific, no? Function. And remember, step 1 is compute that part. Compute that part of the formula. It's super easy because you replace x for x plus h. X plus h squared minus 5 times x plus h 6. And now you apply some elementary algebra. Let's do it. You foil. Ay, carajo. Okay, here, over there. What's going on? Okay. You know very well that that part is x plus h times ECL. you FOIL or you apply quick FOIL, que I suppose que you know, que is square first, plus twice multiplication both x and y together, plus h squared. Do you remember this or no? Or you are doing using FOIL always?
I remember this.
You remember this. Okay, this is the, and this level, college algebra, the student remember this. No. I teaching this 5,000 times. Yeah, I found a student get, no, I don't remember. Okay, you apply for it. No problema. Do you want, somebody want to apply for it or no?
No.
Yes or no? Come on. No. Don't intimidate with me. Si you need to explain in detail, I explain in detail.
No.
Now distribute it here because it's monomial and time binomial. Entonces minus 5x minus 5h plus 6. Cool. I did step 1. The step 2 is the most important step. A subtraction. This expression I found before minus the original. I copy, bring down x squared plus 2xh plus h squared minus 5x minus 5h plus 6 minus this guy. If you want, of course I don't. If you want, you copy again this, pero enclose in the parentheses. But another smart way and fast way is this minus affect everything. So it's easy to understand that you change totally the sign of the original function. Okay? Ready. I am ready to see. This is important part. Cancel out that part. Cancel out that part. And cancel out that part. And stay alive. 2xh plus h squared minus 5h. Yes or no?
Yes.
Finally, step 3. Divided by h. But divided by a monomial is super easy. Because the only thing you should do is divide everything separately like that. Divided by h squared divided by h minus 5h divided by h. So I split this h and the denominator in 3h. And now simplification. This and this say goodbye. 2x plus 1h because h squared divided by h is only 1h minus 5. This is cancel out. End the story. This is my final answer of the famous difference question that we are using in Calculus 1. But we study now in algebra, anticipation. You don't understand very well the meaning of that, but okay. It's important. And this is one application of the function notation. So one application is this, another application of the function notation is transformation. To understand transformation, you need to understand function notation. Okay. No problema? No problema, right? Erase?
No problem.
Yes.
You copy in your notebook or you take a screenshot. What is the way that you using to, or no, you can see the video on YouTube, no? Slow down. You understand the basic idea. Just that you re-watching the video on YouTube and copy, no? Because in the video you can pause. Curiosity. What is the way you copy immediately? Follow me or copy after, or you never copy?
I take some notes and take a picture too.
Okay. Another opinion?
I copy in my notebook.
Exactly, but in the same time,
I
can you
do
explain?
both.
Okay, super. There are many ways. This is the beauty, guys. of the, okay, there are many options. Screenshot, screenshot. Apolinario is a screenshot. Super. Okay. Now let's move on to the question number 15. It's easy, it's okay. This is the distance formula. Oh, we have 2 points. Distance between P1, P2 segment, connecting 2 points, is equal square root x2 minus x1. This is the formula. Square plus y2 minus y1. And of course, who is x2, y2? This is the component, no? The x component or the y component of the specific point. P1 is given, P1 is 3 radical 10, comma, minus 2. And P2 is separated by semicolon, is another point, que the component are 5. Radical 10, comma. Okay, and this is x1, and this is y1, and this is x2, and this is y2. So first of all, in the formula, I subtracting the x component, que is actually. And you open big square root. Open 2 parentheses, put a square in the middle, and you subtracting the x component is this minus this in any either order. But let me respect the order, but this is not important. 5 radical 10 minus 3 radical 10. If you are doing backward, 3 first, doesn't matter because the only difference is negative sign, but when you square become positive. So basically, super easy. You're subtracting the x component. And either way, it's 2 minus 1 or 1 minus 2. Doesn't matter. And the y exactly the same. And the y are, let me use in red column with the y part, y component is y2 is 1 minus, double minus, the minus of the formula. But what, unfortunately, y1 is negative 2 and become positive. I don't know, so you want to put directly, or you put this stupid double negative, no? Negative 2. You know very well that double negative become positive. Yes or no? Yes or no? Yes. It's a plus 2. Because the formula have a minus, look at that. And the value is negative. Okay, so let's compute one by one parenthesis first. Well, big square root again. This is 5 minus 3 is 2 radical 10 square plus 1 plus 2 is 3, 3 squared is 9. Cool, we almost finished. Now you square power. This is a monomial. Entonces 2 squared, so 2 radical 10, let me copy here separately. Square is 2 squared times radical 10 squared. And 2 squared 4. And radical 10 squared is obvious que 10 because the square and the square root cancel each other. F40. F40 plus 9 49. And the square root 49 is 7. Final answer. 7 is the distance in between this point. Super cool, super easy. Do you understand very well the arithmetic part?
Yes.
Cool. Entonces, normally in the test, I don't know why. This test is doing by the department, no? Mathematical department, any campus. Entonces, they introduce irrational numbers like radical 10, radical 7, radical 5, because I want to you practice irrational number. But it's okay, it's not important. It's a no big deal for us. Okay. Let's move on to the next question. The next question is midpoint. Wow, midpoint. We have 2 points again, midpoint. P1 is given, is 4.2. Oh, the only complication I see here is a decimal number. That's okay. We use a calculator, of course. Don't worry too much for this. 1.7 comma negative 3.2. It's a given. This is my x1, this is my y1, this is my x2, and this is my y2. And the formula for the midpoint, x midpoint, is the average. x1 plus x2 divided by 2, and y midpoint is y1 plus y2 divided by 2, the average in between. So x1 is 4.2 plus 1.7, you add in the x component like that, bam, bam, divided by 2. And you add in the y component, let me use in green color, bam, bam, and divided by 2. So it's negative 7.8 plus minus 3.2 divided by 2. Again, we have the situation of the stupid double sign. You know, the positive and negative together is negative, no? So now you want erase this, you put minus 3.2. Okay, let's do it in the first one. So put in the calculator, no? 4.2 plus 4.7 5.9. Obvio, no? Divided by 2 is 2.95. Okay. And this is 7.8. This is obvious it's 11, negative 11. But let me check it out with the calculator. 7.8 minus 3.2. Oh, it's 11. It's 11, right? Minus 11. Divided by 2. And 11 divided by 2 is 5.5. I guess so, no? 11 divided by 2, 5.5. Negative, of course. Negative 5.5. Therefore, our famous midpoint is located at the point. The component is midpoint in between the segment connecting P1 and P2 is located at the position 2.95, comma, negative 5.5. In the story. Cool?
Yes.
Midpoint and distance. One question of this in the test. You see the test. Everyone have the test, no? Did somebody don't have? Let me know. Yeah, I sent in particular. But email me. Okay. That's easy. Let's move on to 17. No? 17 can look like complicated because it's the circle. It's a circle. It's a circle. Okay. So one equation of the circle is given is, let me copy, x squared plus y squared plus 8x plus 4y plus 16 equal to 0. This, unfortunately, they are bad guy. Always give me in the general format. But I need to transform it immediately in a standard format. Standard is something like that. X minus h squared plus y minus k squared equal r squared, where h comma k is the center point and r is the radius. And when you get this in your hand, allow you to do the graph of this. You're doing by hand or Desmo, either way. Okay. So now remember the organization of this by completing the square. You copy the x only separately. You put the magic number for the x, and you copy now the y. And so I open two boxes. I move it in minus 16 to the other side. Yeah, I put two boxes. And now I take all the time to determine the matching number, no? The matching number in the first one here. Let me use the matching number in the X part and the matching number in the Y part. Who help me with the X part? Do you remember the formula to find the
Yes,
matching?
16.
Yes, come on. It's what? 16?
16
I don't understand. Repeat again, please.
is 8 divided by 2 is 4, and 4 is for 16 exactly.
60. It's like 60.
Mhm.
Okay, 16 now, 16 here. Boom, 16. It's a magic number. And what about, no, Elisa, another participation, guys. And the second magic number and the Y. Nobody knows that?
4.
Again, Elsa. 4 and 4, it's obvious. Do you understand this or no?
Yes.
Apolinario is right. Yeah, Apolinario. Yes, this is okay. Okay, to say no necessary repeat again. This is 16 and this is 4, no? I suppose that everyone understand very well where I come from this 4 and where I come from this 16. To say you put 16 and 4 in the right hand side because I want to have equivalent expression, no? So you introduce artificially because you want or you need 116 in the left and you put another 16 in the right, well, okay, no problem, because stay the equilibrium of the equation. Now the factorization, this perfect square trinomial, is x plus 4. Do you understand this factorization? And the factorization, yes, is y plus 2. Oh, in the right hand side, 16 is cancelled and it stays 4. Wow, amazing. And this is my new equation, que es equivalent 100% to the original ugly, que nobody understand, but now it's clear, at least for me. So where is located the center of this circle? And where is the radius of this circle?
The center is -4, -2. The
Super.
radius is 2.
Radius 2. Okay, be careful, because the sign in the point center is opposite sign to the equation. So because look, in the standard you see minus and minus. Wow, why in my example I see plus plus? Because the reason is we have double minus. Because CH and -4, when you plug in -4 here, -4 and H, you replace, but we have another negative outside, double negative become positive. This is the reason that positive in our example. And the other mistake, the student believe that 4 is a radio. No, 4 is R squared. Look, compare this equation and this equation. R squared. Therefore, R alone is square root both sides. It's 2. It's 2. Okay, now the important moment. When you understand this, you finish? No. Because the question say, do the graph of this. I need to do the graph. Okay, let's do it. Let's do it. My graphic, rectangular coordinate system, where it is? Suppose que here. I don't like too much this rectangular coordinate system, but it's okay. Guys, I accept perfectly that you are doing Endesmos and you make a screenshot and attach the test. Either way, the way you prefer. Okay, so the center is located at the point -4, -2. -4, let me use that color, -2. This is my center. Yes or no? -4, -2. And the radius is 4. And 4, 1, 2, 3, 4, upward, 1, 2, 3, 4, downward, 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. It's complete outside, but it's okay. And
Professor,
uh-huh.
the radius is 2.
Ah, yes, it's 2. The radio is 2. Yes, thank you. The radio not 4, it's 2. The problem is I don't see that part. Look here, it's 2. It says 2, yes, good, better. Because in the test I provide, rectangular coordinate system. So you are doing the graph, you have to option. So the test was created to do the graph on the rectangular coordinate system. And si you make a decision doing by decimal, entonces no. You are doing the screenshot and put attachment. Entonces tú in any direction. To upward, to the right, to the left, and downward. Wow, and this is my circle, look like that. By the way, no, good. Okay, don't worry. The problem is to get the whiteboard when I doing the back fixer, no? Not fix exactly. It's just I cannot move. I cannot. But do you understand, right? Yes or no? This point is a point negative 4,0. This point was negative 6, negative 2. This guy was negative 4, negative 4, no? And this guy was negative 2, negative 2. It's a coincidence. And the center, wow, the center is negative 4, negative. Cool?
Yes.
Okay. Cool. Last page. Over there. Okay, last page. Okay, this is we have the collection of the different functions. It's a typical question. I complicated here too much. Let us know, but it's okay. So you understand this? You have no problem with the test. Okay, what is the idea? The idea is, remember, domain. What should I do? You assume que the domain is all real number except the restrictions. And restriction we have in these situations. Restriction number 1, P divided by Q, fraction. P divided by Q, what is the fraction? The restriction is Q never would be 0, no 0. Restriction number 2, radical 1 expression. The expression non-negative. Non-negative mathematical means positive or 0. Non-negative. And restriction number 3, E divided by radical E. So when the radical is in the numerator, accept 0. The radical is in the denominator, do not accept 0. It's only positive. And their combinations, because we have several radical, we have several fractions. Together, you create the compound inequality. You solve the compound inequality and you determine what is the bad guy in the game, and you put outside. You put outside, you doing the number line, and you see clear what it's doing. Doing. Are you clear this idea?
Yes.
Yeah, because some students don't understand this. Okay, Anika is a yes. Elsa is a yes. Okay, let me erase everything. Let's do it one by one. Okay, this is not easy. Okay, suppose the first one. The function is given f of x equal 4 over radical x minus 3. Okay, entonces you see radical in the denominator. We use restriction 1, restriction 2, or restriction 3. I suppose que restriction 3. So you take the expression inside the radical, get this, and you enforce it to be positive only, right? And you solve this elementary negative inequality case x greater than 3. Okay, okay. Now you want to see more clear. Create your own all real number line. I like so much. And the elementary example maybe no, but in the compound always you ending graphically like that. This is the line can represent all real number, infinity positive, infinity negative, 0 in the middle, 1, 2, 3, and the domain is from 3 to infinity, that part. Of course, do not include, no include 3, because I don't see equal sign. Es obvio que no, because 3 minus 3 is 0, or square root 0 is 0, and division by 0 is fine. So what is the answer? The answer of the domain, I want to see like that. Domain of f function is equal parenthesis 3 comma infinity. And this function interval notation, sorry. Interval notation. Forgot to say here, interval notation. And it is, yes, specification, interval. Is the notation more clear? Another is confused. You can write like that, x such that x greater than 3, and in the story is equivalent. But in order to avoid any confusing in the test, international, there is interval notation. Clear?
Yes.
Let's move on to the next. Next is another function, different name, SG, and this look like more complicated because we have one radical in the top and one radical in the bottom. So remember the assumption is all real number except the restriction. How many restrictions you can see? How many restrictions you can see?
2.
2. Are you taking this expression inside and this expression inside, and you copy x plus 5 non-negative and 6 minus x positive. Do you understand very well this one?
Yes.
And you need to find the bunch of value, the interval, to satisfy both conditions. You solve it, you have in this moment, you face one compound inequality. You solve it one compound inequality, one by one separately, and finally we connect it in the number line. So S here is x greater than or equal negative 5. Done. And this is a little bit more complicated because it's negative x greater than negative 6, right? And you divide by negative 1 because I need positive x, no negative x. And you need to remember that when you divide by negative 1, it's a negative 1, you reverse the inequality sign. So actually, x alone is less than 6. Okay? We have two pieces, this piece and this piece. I put together in the number line. Okay. Infinity positive, infinity negative, 0 in the middle, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 5. Okay, that piece is greater than negative 5, including negative 5. But that piece, in my mind, is from negative 5 to positive infinity, like that. I do not highlight directly on the number line because this is the partial solution, no? I want to highlight definitely when you have the final answer. But suppose the other piece, que es this piece, is in 6, from 6, no include 6, no include 6, and is in that direction. Okay? Now I need, it's a super important crucial moment, perform the AND operation in between the pink color and green color. What do you think? ¿Qué se hace? ¿Es de pink? ¿Es de green? O I don't know. Opinion, opinion. Opinion que you are a student in college. A ver. Ese, Anika say, it's the green part, professor. Everyone is agree with Anika or no?
Professor, I'm confused because is x greater than 6.
Ah, yeah. Me too. I am super confused. Sí. Hello. I think you all are here living. Okay, es obvio que this part is in that direction. Yes or no? Because less than, coño. It's to the left, ¿no? Entonces, bueno, entonces rectification, Anika. ¿Es de green, es de pink o es in between both? Yeah, es in between because es and mean common element. Okay, entonces es, let me using another color, maybe gray color to the final answer. The final answer is this. Is the common part. And what about 6 and -5 belong or no to the solution? No, 6 definitely no, because I don't see equal sign here. But 5, yes, bracket here. The domain of the famous function g is bracket 5, bracket -5, comma 6 parentheses. Any point outside this is completely outside the domain. Okay? This is clear or confused?
Clear.
Clear.
Let's move on to the next. Whoa, the next look like horrible because we have 3 radical and fraction also. Okay, but you don't care. You analyze one by one restriction and finally you put together in the number line and you determine the intersection, que es the common element. Suppose, I copy. H function is equal 8 over square root x plus 3 plus square root x minus 4 over square root x plus 8. Now you copy. Restriction, first restriction I see is x plus 3 must be positive. And x minus 4 must be non-negative because it's in the top. And x plus 8 must be positive. Because in this case, we have a compound inequality, but this compound contains 3 pieces, sorry. And you solve it one by one. The first one is x greater than minus 3. The second is x greater than or equal 4. And the last one is x greater than minus 8. Okay, you put together and the number line. Put together and the number line. Is infinity positive? Is infinity negative? And you have, for example, 0 in the middle, 1, 2, 3, 4, 1, 2, 3. This is -3. I suppose que -6 here. Let's do it one by one using different color. Okay, maybe it's good to understand this. Suppose green. This guy is from -3 to infinity. It's okay? You correct me if I make a mistake, because I make a mistake every day. Okay? Now, I'm using pink color, I like so much. Pink color is from 4 to the right also, no? The endpoint is included here and not included here. This is not important now. It's important in the final. And this is greater than -8. Let me using another color. I don't know what color is good. Suppose blue or that cyan is -8. It's something like that. Okay, I need to find the common part in between pink, green, and cyan color. What do you think? What is the common part? What are the part and what in each interval share? It's a common point. ¿Es de pink? ¿Es de green? ¿O es de cyan? Thinking, es de green. Anika dice, es de green. No, Anika, no. Anika, no. Look, let me show you. This is confusing. I understand very well. Suppose state of Florida. It's like that. And this is Miami, okay, our city. And it's in Florida. So when you see, for example, if you living in Miami, this is you living in Florida or no? Yeah, because every element. However, one guy's living in another city, for example, Orlando, is not living in Miami. So Miami belongs to the Florida. So you need to satisfy the condition. Okay. So you are here. It's obvious that you don't satisfy the green part. You satisfy only the cyan part. Suppose that another point here satisfy the green, cool, and satisfy the cyan, but do not satisfy the pink. One guy here, like a 5, like a 6, satisfied pink, green, and cyan. Do you understand now?
Yes.
Entonces es obvio que the domain of this complicated function, okay, is only from 4 to infinity, including, of course, 4 and infinity, always you put the parentheses. Super. Okay. Let's do it one more. Oh, no. Yeah. Do you understand this? I want to discuss in another topic. This is the same stupid thing. Yes, do you want to do D and E or no? I want to discuss it because some student asked me one question and the Alex, okay, I would like to discuss it. Elsa, remember your question?
Yes.
Let me try to explain. Okay. Number one, let me try to find the image I created for this moment. There you go. Do you feel strong? And this classical question gets determine domain when the question is given, no? Do you feel strong?
Yes.
Okay, now let's move on to this question gets confusing. Of course, I don't know explain because I cannot have time to explain everything, no? But I take advantage of this. So now it's about composition. Composition, what is the interpretation of the composition? Composition is, you have two functions, the function f and the function g, for example. Entonces, in that order, so my first function is f and my second function is g. So basically, is g composition F. Remember, you copy the name of the first function when you have the inner function is F, and this is the outer function is G. And this is completely different if you interchange the name of the function. So in general, it's not the same. But in this problem, it's given no equation. It's given a Aron diagram. Aron diagram. So this is this part is the domain of F, and this is the range of F. And this is the domain of G, and this is the range of G. And I want to connect in that function in this order, Therefore, F is the first one. It's obvious, no? This is the input. Yeah, I suppose that this is the output when you finish. And what going on in the middle? Okay. The range of F is formed by the number 1, 2, 3, 4, 5, and 9. And the domain of the function G, que es the second, no? Yeah, the second, is 1, 2, okay, good, 3, 5, and 7. And the intersection range of F, let me denote like that, range of F, intersection, domain of G, que es the common element between these, is obvious que 1, 2, 3, and 5. And 4 no, and 9 no. Okay? Entonces, the common element is 1, 2, 3, 4, and 5. 9 no, and 7 no. Do not participate. So the connection that you stay in between the element is this. Ching, 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 and 4 no, and this. 1, 2, 3, and 5. Okay, this no. Therefore, to stay this connection in between G and X, for example, you see que 2 is okay. Why is okay? Because they are connection here and here. 3 is okay. Because we have connection here, here, and here. 4, I don't know. Yes, it's okay because the connection here, here, and here. And 5, no, because the association with the 4 and 4 disconnecting with the another. Do not connect this. And 8, yes, because it's 2, 2, and 5. This is the reason that the domain of the composition is 2, 3, 4, and 8. Do you follow me? Do you follow me?
Yes.
Now, what about the range? Well, the range is, suppose the trajectory start in 2. Let me use another color. 2 connecting with this, and connecting with this. Absolutely 0 is okay. 0 belongs to the range of the composition. Suppose another trajectory, 3. 3 and 5, 5 and 5, and 0. 0 again, repetition 0. 4. 4 connected 3, 3 connected 3, and 3 connected 3. Oh, 3 is okay. What is the next? The next is 5, no. 8, yes. Is this, is this, is this, is 5. Wow, final answer. This is our range of the composition function. Super clear?
Yes.
Cool.
Yes.
Okay, entonces now let me spend the rest of the time, que esté menos, ¿no? Doing the problems here of the domain, no? How do you feel for this test? How do you feel? How do you feel? 100 points for everyone or not? No?
Yes.
Uh-huh. Okay. Domain of this. How many restrictions and which one you can see in this expression? Remember, restriction is fraction or radical. And radical, we have two scenarios. The radical on the top, the radical on the bottom. What restriction you set up in this case? Tell me. Who help me? Come on. Yasmin, Michael, Anika, Apolinario, Yamori. Come on.
Um,
Gloria.
the denominator different than 0.
Okay,
Distinct
que es
than 0.
x minus 3, no 0, right?
Yeah, no 0.
And x
And
minus, again, yes or no?
yes.
Cool. And what is the last one? Restriction?
The x plus 5
What?
greater than 0.
Greater than or
equal.
remember, radical on the top, allow 0. Radical on the bottom, no. And you solve it one by one. Entonces, no 3, no 3, no 4. And this is greater than or equal minus 5, correct? Correct?
Yes.
Yes.
Let's doing this idea in the number line to visualize the domain. This line represents a real number. Actually, 0 in the middle. And 3 and 4. 1, 2, 3, and 4. And negative 5 is in another direction. No, I suppose get here. Minus 5. Okay. What mean no 3? The idea is que in 3 we have a hole. And what mean that? In 4 we have another holes. And greater than or equal to negative 5 is in that direction. In that direction. Let me use in pink color, maybe good. In that direction. In that direction, no? Of course, include negative 5 inside the game. Now be ready to determine what is the domain. I plug it in, I put a graphic, this restriction. And this restriction, when it's not equal, represent whole, right? Entonces, en my opinion, es obvio que this part is okay. Stop in 3 no. And between 3 and 4, we have infinity number with decimal, no? And after the 4, yes or no? And continue forever.
Yes.
Now, domain of the function p, you declare it like that, of the function p is equal, bracket from negative 5 is good guy, comma, 3, stop in 3, no touch 3. Remember, we have 3 pieces. This is my first piece, this is my second piece, and this is my third piece. And any piece you separate by union. And between 3 and 4, 3.1, 3.15, in union, 4, infinity. End the story. Cool?
Yes.
Okay, one more, and you help me. You say it's easy, guy. Also, we are good teams. You pay attention, you stay here with me every lectures. Now you understand because I explained super clear. I suppose, it's my supposition. You let me know and we modify a little bit to improve. Prove me, maybe. Okay? Okay, who help me with the next one? It's the last one. And that's it. M function is the name of this. Is square root x plus 2. Wow, plus. square root x minus 2. Wow. Plus 1 over x minus 3. Okay, who helped me to set out the restrictions in this scenario? Come on, guy.
We have 3 restrictions.
Which one?
X plus 2 greater than or equal 0.
Always you're connected by and. Do you understand why you're connected by and? Because you need to satisfy one, satisfy and the other, and the other. Likewise, this is x minus 2 greater than or equal to 0. And what is the last restriction?
X minus 3 different to 0.
Exactly. Let's do it quickly. This is x greater than or equal to minus 2. This is x greater than or equal to positive 2. And this is x not equal to 3. Okay. And the number line look like that. This is my famous or real number line. Infinity positive, infinity negative. 0 in the middle. We have 1, 2, and 3. And negative 2, 1, 2, negative 2. And 3 we have a whole, obviously. But in positive 2 and negative 2, we have that situation. We have in 2 like that. In negative 2 like that. Remember, everything is to the right because the idea is that the numerical expression inside the radical must be positive. Because I know que si es negative, it's imaginary. So to avoid the imaginary number, the inequality always is greater than 0 in one direction. Now I need to find the intersection between pink color, cyan color, and of course include the whole. No? Who help me? Do you understand very well this or no? Do you understand que, for example, the cyan color is the state of Florida, and Miami is completely inside the state of Florida. So the pink color is totally inside. You want to find one city same que satisfy both conditions. Es obvio que es de pink, ¿no? Make sense que es de pink?
Yes.
Yes. Entonces, from 2 to 3, of course, include 2, because I see equal sign here, and from 3 to infinity. So the domain would be bracket 2, 3 parentheses, union 3, infinity. End the story. We finish. Okay, entonces we start Wednesday, new chapter. It's a little bit more complicated. Okay. Okay, guys, see you Wednesday.
Thank you, Professor. Bye.
Thank you. Bye,
Professor.
Professor.